This is a live demonstration of the mortality modeling agent. The agent utilizes OpenAI's GPT-5 model and has access to several powerful and clearly defined tools for analyzing and smoothing mortality rates. The agent is able to perform data exploration, identify data quality problems, analyze deviations in claims versus an expected basis, and, most impressively, build complex mortality tables. This demonstration uses the SOA's ILEC data, which is a large database of individual life mortality experience. So the agent finished, and now the question is, did it do something useful? In order to get comfortable with all the things it's telling us, we should turn to the modeling log. First, we'll look at the SQL queries that the agent ran and run them ourselves. Next, we'll look at the formula for the model that it built. We see that it applied additional data cleaning operations before building the model. Looking at the model performance on 3 holdout years, we see it needs a face amount factor that varies by underwriting class, but the overall A over E is 102%. We can export the model as a spreadsheet of factors in a format familiar to users of actuarial projection software. Next, we'll export a spreadsheet of the model's predictions versus actuals and expected, grouped by age, using the integrated query editor. We'll address the shortcomings we found during validation by rerunning the agent using a custom prompt. First, we'll provide the agent with the previous model's formula as a starting point. Next, we'll adjust the agent's goal by vaguely telling it to closely follow the face amount versus preferred class interactions shown by the decision tree plot. Repeat the same steps we saw previously to validate the model, examine its predictions, and export the factors to Excel for use in actuarial projection software. We'll compare the decision tree plots for the first and second model to see if the agent improved the model's performance on the holdout set. We've just watched the agent build 2 models. The first model keeps it simple, and the second is substantially more complex. Both produce 102% A over E on the holdout data, where the expected basis is now the model predictions. The biggest difference between the 2 models is how the factors used in the model prediction vary. In the first model, they vary only by 1 factor at a time, for example, age. In the second model, they vary by up to 2 simultaneous factors, like age and underwriting class. Keep in mind that the 2015 VBT table QX is also included in the prediction, and it varies by age, sex, and underwriting class simultaneously. It also includes calendar year mortality improvement. That was a lot of words to ask a simple question. Is the additional complexity of the round 2 model worth it? Depends on the context. Determining which of these models is better is still an entirely human task.